This is the most fundamental concept in SQL. If a candidate doesn't know the logical execution order of a query, they cannot debug complex pipelines. Interviewers use this simple question as a Trojan horse to test if you actually understand how the database engine reads your code. Before you write a single line of SQL in an interview, always verify the data model. In this problem, we are given a products table. It has 3 columns: a product ID, a low fats flag, and a recyclable flag. Our goal is simple. We need to find the product IDs for items that are both low fat and recyclable. Now, here is the most common beginner mistake. You write your select clause, create a clean alias called isHealthy, and try to filter on it in your where clause. You run the query, and the database throws an error. The alias does not exist. Welcome to the invisible trap of SQL execution order. Unlike Python or JavaScript, SQL does not read your code from top to bottom. The database engine executes your query out of order. First, it runs the from clause to load the table. Second, it runs the where clause to filter the rows. Third, it runs the select clause to choose the columns. Because where runs before select, your is healthy, alias is completely invisible during the filtering phase. To fix this, we must put our logical conditions directly into the where clause before the select clause ever executes. We ask the database to check if low_fats equals y and recyclable equals y. By placing the exact predicates directly in the filtering phase, the database evaluates every row perfectly without needing any aliases. Here's a senior level detail to mention to your interviewer. What if a row has a null value in the recyclable column? SQL uses 3-valued logic: true, false, and unknown. Comparing null to y evaluates to unknown. Because a where clause only returns rows that evaluate to true, the null row is safely filtered out. Mentioning this proves you understand edge cases. To recap, never alias a column in the select phase and try to filter on it in the where phase. The mental model you need for every interview is this. SQL reads your from clause first, your where clause second, and your select clause last. This simple ordering blueprint is how you pass the execution test every single time. Let's analyze the aliasing in select and filtering in where approach. Time complexity, NA, space complexity, NA fails to compile, throws a syntax error because the alias does not exist during the where phase. Let's analyze the direct predicate filtering approach. Time complexity, ON, space complexity, O1, performs a simple full table scan, evaluating the Boolean predicates row by row. The interviewer will then ask, why did your first query throw an unknown column error? Because SQL executes out of order. The database reads the from clause to load the table, then evaluates the where clause to filter rows. It hasn't processed the select clause yet, so the alias I defined there literally doesn't exist in memory when the where clause runs. The interviewer will then ask, how would you optimize this query if the table had 1 billion rows? Since this is a simple point lookup on 2 categorical columns, doing a full table scan would be expensive. I would recommend adding a composite index on both the low_fats and recyclable columns. The database could then use an index seek to find the matching rows instantly without scanning the entire table. The interviewer will then ask, what happens if one of the rows has a null value for recyclable? SQL uses 3-valued logic: true, false, and unknown. When comparing null to the string, y, the result is unknown. Since a where clause only returns rows that evaluate to true, the row with the null value is correctly filtered out. The interviewer will then ask, if you absolutely had to filter using that alias, how could you do it? I would have to wrap the select statement in a CTE or a subquery. The inner query would execute first, materializing the alias, and then the outer query could filter on it in its own where clause.